So far we have got some understanding of what my data looks like and what kind of graph I can create, and we talked about bar plot and histograms, and I just wanted to talk about a very important graph over here, and that graph is called box plot. And I absolutely love this box plot concept, and the reason why I love this box plot, because it actually helps lot, you like more than you can think of in terms of data analytics. So what this box plot does, and just wanted to talk about this. Okay, now just think, let's say I have a line over here. So let's say we wanted to let me just pick up this example. Okay, so we have some students, and in these students we wanted to calculate their marks. Okay, and these marks in their mathematics. So we have got some people, so that we have number of students and we have marks over here, right? So not let's not take about the number of students. Let's say like how many marks they get. Okay, so some people get in mathematics, they got 65 out of 100. Some people got 60, some people got 70, some people got someone got 90, 99 and 95 also. And there have like students who got 45, some student got 65, some student got say 55, and so on and so forth. There are different numbers, right? There are n number of possibilities out there. But how would you represent this whole information? So if I have a line over here, right? So I'll just take a copy of this line. Okay, and if I'll just take line over here, and I can say that the minimum number, so I'll just define this. I'll say minimum number somebody got in the class is 40, right? And this is the point. And then we've got 50, then you have got 60 over here, then you've got 70, then you've got 80, then you've got 90, then you've got 100. Okay, and the line ends over there, right? Line ends over there means that we do not have marks beyond 100, right? So some people got 100 also, right? These are the people who got the marks. Now just think, okay, just think over here, right? That if I wanted to pick up some points, so maybe I'll just pick up a different color so that you can have a look, right? So we can say that some people got marks over here, some people got marks over here, some people got marks over here, some people got mark over here. Most of the people got marks over here, right? These are the people who got, most of the students are getting marks, and they have like various people who got marks over here, but very few people got some marks nearby, and there's one guy who got this kind of marks. Okay, now how would I represent this information, right? So if you say that, if I ask like what is the range of the people who got the marks, so this is the minimum and this is maximum, right? So my range of people who got the marks is defined as 100, which is the maximum, right? So I'll write max over here, maximum minus minimum marks obtained. So 100 minus 40. For example, there is another subject called physics, right? So we can have a different range, right? So we can say physics, people get the marks from 55 to say 95, right? And the range of the physics would be equal to 95 minus 55, which is 40, right? So range basically helps us identify like how much scattered my values are. But I'm not basically I'm not like counting on this thing, physics thing, but I just wanted to tell you that this is how you calculate. So you can compare various values over here, and we'll talk about that in a minute. But we have a range over here which is 60. So 60 is the range of the people who got different kind of marks over here. So I wanted to represent this information, but I have got no clue. And somebody asked me like, what do you infer from this data over here? and I say like some people got the marks in 40 to 50 and some people got the marks like 50 to 60, and it doesn't make much sense, right? So if I wanted to represent this information, I can of course use the dot plots to define this, but it might not be able to infer the good infer like the exact information which I'm looking for. And to represent this kind of information, we often use box plot. And how exactly it works, now I want you to just look at this. Okay, I'm picking up this line, the same line which I have created over here. So I'll create this line over here, and I'm representing the same information, right, so that you don't get confused. It's the same line. And I wanted to say that, you know what, if you calculate these marks over here, the most of the people, right, the middle 50%, middle 50%, okay, I'll just say middle 50% of the people got the marks between 70 to 90. Okay, and how would I represent this information? Now when I'm saying this middle 50%, what do you mean by middle 50% of this data? Okay, now just think, if I divide my data into 4 equal frequency bins, if I divide my data in 4 equal frequency bin, how would I divide that? So say there are say 100 students. So if I divide in 2 equal frequency bins, the 50 students, like if I sort the data in ascending and descending order, 50 students will lie over here, and there will be a middle point, and then the 50 students marks will be lying over here, right? So I'll say 50 students mark will lie over here. So we have equal number of equal frequency bins. So there will be a point, somewhere here, right, where I would say that if I sort this data, these are the 50 students who got the marks below 74, and there are like 50% of the student got the marks. So this, I'm writing a percentage over here, 50% of the student got marks which are greater than 74. So what I wanted to do is I wanted to mark my median value, and if you remember, this is the exact definition of median, right, which is dividing the data into equal frequency bins. So I have got median over here, right? Now if I further divide these 50%, like say I'm talking about this 50% over here, right, if I further divide this into 50%, probably I'll get some marks over here, which means that 25% of the people got these many marks, 25% of these people got these many marks. And if I divide this further, this part, right, so I'll just change the color. 50% of this people, some people got marks over here, 25% got these many marks, and rest 25% got these many marks, right? If I wanted to represent the same information over here, I will use box plot for that, and I want you to remember this. Okay, now what am I gonna do is I'm going to remove my images to this side and use this images so that I can better represent my data. So I'll just pick up the same line over here once again. Okay, I'll just take it even on the little lower side, and I'll copy this as well, right? So I would say that 25%, you know where the point is lying exactly, right? It is lying somewhere here, and I would try to represent this information something like this. Okay, something like this, which means now if I have like my median value lying over here, this value lying over here, I have minimum value over here, and I have maximum value over here, and I would like to call this value as minimum, and I would like to call this value as Q1, which is quartile 1. I would like to call this value over here is Q2, which is my median value, and I would like to call this value over here is my quartile, which is Q3, um, and this is my maximum, right? This is my maximum value. So I would like to represent this information with the help of this box plot, and this is how it looks like. Okay, I am not sure if it will just do the justice. So I will pick up this, I'll pick up this line, I'll remove it, and I will just create one line for you guys. Okay, so this is how my box plot will look like, and I would remove the middle part of this, right? Something like this, something like this. This is exactly my this is how box plot will look like. So there will be a point which will define the median value. Okay, and so we'll have, and generally this summary over here, right, which you're seeing, right, Q minimum, Q1, Q2, and Q3 maximum, this is called 5-point summary, and we are going to use this a lot, guys. We are going to use this a lot. So this is called 5-point summary of the data. Okay, I repeat that I want you to remember this concept, because this is called box plot. So why this is called box plot? Because we have a box over here. This is my box, and we also have something called as whiskers. So I'll just change the color over here so that you can, these are these values over here. These lines are called whiskers of the plot, whiskers of the plot. And this, we'll talk about that later, but not right now. But this box plot is very much useful in identifying outliers as well. So we'll talk about that. We'll take some time to absorb the concept, but this is called box and whisker plot. So my box and whisker plot has got most of the time these kind of values, and I wanted to use this value for different purposes. Okay, so now what we want to understand is that if, let me just do this, and let's understand why we use this box plot. Okay, so I'm just going to delete everything from here, and I wanted to give you some idea. Okay, so I have a box plot, I have a line over here, and I'll just make it a little horizontal. Okay, and this is how my line looks like, and this is my box, right, which I'm using, right, and I will just, I'll say color of this box is somewhere like this. Okay, so this is my one of the box, right, and what I want to do is I wanted to create one more box plot over here, and I would like to explain those box plots to you. Okay, this is one of my box plot, and I would say I have one more box plot, and this is how my box plot looks like. Okay, one of my box plot looks like this. What do you infer from these box plot? And I'm going to create one more box plot where I have values like this, right? And how do you infer this box plot? This is what I wanted to understand from you. Okay, now how do you infer these points, and how do you make sense of these points is something like this. And I want you to understand this as one of the concept which we use for analytics, right, which is very much helpful and very much and generally don't get explanation for this, and I really wanted to make you understand this. Okay, so let's see, if I wanted to create the graph of this, okay, what would be my graph like? So I'll be creating a bar over here, and I'm shortening the bar. I'm shortening this bar a bit. Okay, and I'll create one more bar, one more bar, one more bar, and what I wanted to do is create a graph like structure for you. Okay, this is how my graph looks like. And how would I draw this? Something like this. Okay, this is how my graph will look like. And how do you interpret this graph? How do you interpret this? If this line is a little bit extended, how would you interpret this graph? I will tell you. So basically this graph shows that middle 50% of the data, like, so just this is my minimum. I'm writing this down over here. Minimum, we have Q1, we have somewhere here we have Q2, and we have Q3 values, and we have maximum values. So here, if you represent this graph over here, you have, this is your minimum value, this is your maximum value, okay? And you just wanted to explain this, okay? You wanted to explain where exactly middle 50% of your data is lying. So this is your Q1, this is your Q2, and this somewhere here is your this is Q3, and this is somewhere Q2, which is nothing but the median. I'll just write median over here, right, so that you can remember it, right? So you will say most of the people are, like, 50% of my population is lying between this area, right? This is the area where most of the people are lying, and this is the next 25% are lying over here, and the lowest 25% of the people are lying over here. So you can actually represent this data with this graph. Now this is the representation of this graph. Now let's talk about this graph, okay? How would this graph will look like? So how would this graph will look like? You need to understand, right, in a little different manner. So I'm just going to draw another diagram for you, right? And this is more of a perpendicular, you can think of this way, and I will extend it a bit, right, so that I can draw. Now over here you can see that lowest 25% has got the biggest tail. So this is 25%, okay? Now how would you draw this diagram? Something like this, So what will happen? Where would your middle 50% lie? Your middle 50% will lie somewhere in between this and this, right? And your middle value, your Q2 will be somewhere here, right? And your Q1 will be somewhere here, your Q2 will be somewhere here. This is your maximum and this is your minimum. So the same representation of the graph which we have done earlier can be represented over here as well. Now if you wanted to pick up this graph for this data, let me replicate this over here, okay? And I think I can just represent the same line like this. I'm comparing this line over here, okay, something like this. So how would I represent this graph over here? So your most of the 25% of the data, right? So the middle 25, the lowest 25% is lying somewhere here, and most of the 25% data is lying over here. So how would you define this graph? Is something like this. So you will take this line something like this over here, something like this. So you can say safely, or I can just better represent this line something like this. I will write it in one go. It looks smooth, right? Or it will just go something like this. So you will say most of the 50% of the graph doesn't make much sense. I wanted to draw exact number for you. So how would I do that? I would do something like this is 25%, most of the 50%, and then it just dips down like this. It dips down like this over here till last. This is your maximum. So 50% of the data is lying in this, whereas the median value is somewhere here, somewhere here, or it can be here also, it can be here also, right? It can be anywhere, right, depending upon what kind of data you have. So you will, how would you write your, again, this is your minimum, right? This is your lowest 25%, this is your like lower middle, right? And then this is your upper middle 25% of the data, and this is your the the top 25% of the data, right? So you have the box and whisker plot, which can always talk about these kind of matters. When you see the box plot, you have to understand what is lying in between, and trust me guys, it's not very difficult to deal with box plot. It's just that you need to understand how these all things are working. Now what I want you to understand is that you need to understand that how would you compare the two graphs. For example, if I want you to compare this graph and this graph, you should be able to understand that lower 25% of this data is very high, so it has a very long tail, and it goes something like this, okay? So you need to understand this graph, right? So if you can interpret these values, probably it will start making sense very soon, right? A little exercise and little practice on these exercises will make you proficient in all this stuff. I hope it makes sense to you, right? I wanted to talk about some more graphs, and I have very exciting things coming up. If you are understanding all these graphs, and if you have any problem, just write up the questions. In case you do, like in comment, right, if you have any questions. If not, probably I will move to our next graph. We'll talk about more on these graphs, like what are the different kind of graphs you can deal with. I'll see you next.